All right, my friends, welcome to my first ninth grade SHSAT practice test, right? So typically, when I do my, prep courses and stuff, it's just for eighth grade SHSAT. But there's been some requests for ninth grade SHSAT. So the practice tests are a lot smaller. So I'm going to do a few of them. I'm going to do one at a time. So I'll do one here, and then I'll post maybe in a couple days. I'll try to post another one. The material is a little bit more challenging, right? Content-wise, overall, not super different. There's more geometry. Very few spots, I would say, as far as getting in, right? I only know a handful of students that did not get in the first time and got in the second time. I guess probably, panicked on the initial test and then studied a lot more for the second one. But there's not a whole lot of spots, so not to discourage anyone, but it is what it is. So let's get into it. So the first one, nice, easy proportional relationship here. So it says, at the end of hour 5, there's 2,000. They don't really, we should be able to see that from the graph, right? So obviously then that would be 2,000 divided by 5 is going to be 400 per hour, right? And if it's hour 20, we multiply that by 20. All right, so we should end up with, 8,000 at that point. So that should be pretty easy, right? For the second one, it says that this operation is basically just division, right? And the B divided by C doesn't really mean anything. It's just division. So this symbol means division, right? It's 2 divided by 4 divide x. So we know that we multiply by the reciprocal. So really we get 2x fourths, which is going to be x halves. So what we have is that x halves is equal to 3 halves, and there's really not any work to do here. We just can conclude that x is equal to 3. All right, for the next one, this is a pretty easy one, right? So it says, what could be x squared? So we can make x negative half. Let's make it negative 2/3. It doesn't really matter. I'll do both. Right, so then x squared here would be a fourth. Right, x squared here would be 4/9, right? The point is that if x is between 0 and -1, x squared is going to be between 0 and +1, so the only answer choice between 0 and +1 would be U. For the next one, make sure you brush up on your negative exponents, right? We see negative exponents pretty rarely on the 8th grade SHSAT, but we see it a little bit more here. So they expect you to know that 7 to the negative seconds, right? Remember, a negative exponent is just a reciprocal. So that's going to be 1 out of 49. We know that 7 to the negative first is 1 divided by 7, so 1/7. And of course, anything to the 0 power, any non-zero number to the 0 power is equal to 1. All right, so 7 to the 0 is equal to 1. So we want to know how many 49ths this would be. So we're converting everything into a common denominator. So I've got 1 out of 49 plus 1/7, which is 7 out of 49, plus 1, which is 49 out of 49, and that's going to be 57 out of 49. So that should be pretty straightforward there. So that should be choice J. All right, number 5. So we have some similar figures here. So, we don't necessarily need to go through, if we're taking the test, all of the proving, right? In other words, the proving would be, well, what's the point of telling me that they're parallel? Well, the point of telling me that these are parallel means we're going to have parallel lines cut by this transversal, essentially, right? So that would mean that these two angles are going to be equal, right? They're going to be my alternate interior angles. I'm going to have my two angles that are equal here. I'm going to have my vertical angles, right? Point being, I'm going to have two similar figures. So this is my 2 side, so I can call this my 2x side, right? This is going to be my 4 side, so I can call this my 4x side, and this is my 5 and my 5x. Now, x is the ratio from the smaller triangle to the bigger one, right? We don't know what the ratio is. We know that whatever the SW side is, right, from VS to SW is multiplied by something, right? In other words, that big triangle may be 3 times, the small one or 4 times, or 7/3 or whatever times, but we don't know, right? So they want the ratio of WT to ST. So WT is going to be my 4x side, and XT is going to be my 5x side. So essentially, they want you to know that the ratio here is going to be the same as the ratio here, which is going to be 4 to 5. So that's something we typically wouldn't see. We don't see too much with similarity on the 8th grade SHSAT, but we see a lot more of it here. All right, so we're dealing with some scientific notation, right? So one thing we need to understand, right, is that if I have a number, right, let's say I want to express this number, right, that if I want to express the same number with a bigger power or a smaller power, then I need to take my base and multiply or divide it. So if I want a larger power of 10, right, instead of 1 3/10 times 10 to the 7th, if I'm multiplying by 10 to the 8th, that's multiplying by 10. I would have to divide this quantity by 10. And similarly, if I wanted to go down a power, I would have to go up here. So all of these numbers are going to be 13 followed by 6 zeros, right? Now, what we want to do for this question is convert everything into 10 to the 19th, all right? So when I convert 12 and 6/10, I'm going from 12 and 6/10 times 10 to the 18th. I'm making this power bigger. Now, if I'm going to make this power bigger, it means I need to make the number being multiplied smaller. So both of these numbers are going to be 1, 2, 6, and then 17 zeros. So now I know that I'm going to have, my answer is going to be somewhere a little bit less than this number. Okay, so none of these make sense. G could maybe make sense unless you really understand the scale. And if you understand scale, then G is not going to make sense because this is 10 to the 17th. That means there's 2 powers of 10. So if I'm converting this into 10 to the 19th, I need to divide by 10 twice. So I'm moving my decimal 2 places, right? So that's going to be 11 thousandths. So really what I'm doing is I'm taking this number and I'm subtracting this number. So since the numbers have the same amount of place values, I'm just subtracting my initial numbers. So I'm doing 1 26 hundredths minus 11 thousandths, which is 1 260 thousandths minus 11 thousandths. So again, G is if you messed up your place value and you only moved it 1 decimal place instead of 2 for the 17th power one. But we should see pretty clearly then that this should be H. All right, this is a really strange one. I don't mind that the top is cut off here, right? So it says that we want to make the one figure overlap the other, right? So it's going to, obviously the figures, if you look at this, right, it's going to look the same. So they're congruent figures, right? So no dilations. And we want to get the most points. So we're going to say, well, one thing I can do is a 180 rotation, which is like 2 90-degree rotations, right? So the 90-degree rotation gets us 2 points. So 2 90-degree rotations would get me 2 points plus 2 points, which is 4. Now a translation is going to preserve orientation, meaning wherever I translate this figure without doing anything else, it's still going to look like this. It's not going to be flipped. So 2 translations is never going to work. Is 2 reflections going to work? Well, sure. If I reflect this down over, let's say, whatever line this is, whether it's the x-axis or not, okay? And then if I reflect it over, like in other words, if this is the coordinate plane here, right? If it's not, then it doesn't matter. You'd be reflecting over whatever vertical and horizontal line. But let's just suppose that that's the axis. I could do a double reflection, okay? And it says that that's going to be 6 points, right? Translations is not going to work. None of the other ones are going to give us the points, whether or not they work. Now, choice E is not going to work because the rotation is going to make the thing pointed down or up, so the reflection is not going to match the orientation, so that won't work. A translation and then a reflection is not going to work because the translation, if I move it over when I reflect it, is not going to have the right orientation. It's also not going to give me the most points. So I'd want to do a double reflection. So if I did my original reflection, it would look like this. And then when I reflect it over that, let's call it the y-axis, it would work. So we'll go double reflection. This one is one that shows up a lot on the 8th grade test. So we're going to multiply 0 times 5. We're going to multiply 1 times 7, multiply 2 times 3, multiply 3 times 4, multiply 5 times 1. That's going to give me 30. It said there were 20 students in the class. So that should give me 1.5 as my average. All right. We can probably also tell that all these other answer choices are way too big for them to be reasonable, considering the bulk of our stuff is there, right? So considering there's only 2 of these things that are above, and I think that's probably the strategy, right? If there's only 2 things above 3, then any average above 3 makes no sense. Number 9, you just got to interpret, you kind of read the question, right? So it says NR, right? It doesn't mean we started 100, 100. It means that we had the original points, NR, and we did this thing where we added 10. So the x value, right, x plus 10 is 100, so obviously x was 90, and y minus 10 was 100, which means we started at 110. So you're actually just doing kind of the reverse of what they want you to do. This one is kind of challenging, right? So we need to know the formula for the volume of a cylinder, right? So that's not something we would typically need to do for 8th grade, right? So pi r squared h, right? It's the area of the circular base times the height, and that's going to kind of tie into the way we solve the problem. So if the radius is 4, right, we end up with pi times 4 squared times 8. So I don't really need to like do this whole thing. In other words, when I did this, I really just expressed it as like 16 times 8 times pi, right? And I'll explain why, right? Now it says we're putting this in a cube, right, that's got a base of 8, or all of the sides obviously are 8 because it's a cube, my beautiful cube here. Now, really what we care about, right, if we want to know how high something is, we're dividing it by the base, okay? Because in other words, if my base here, right, the area of my base is 64, right, that means in order to fill this up 1 inch, you would need 64 square units, right? So 128 divided by 64 means the height's going to be 2 pi, okay? Because if the height was 1, it would fill 64 units. If the height was 2, it would be 128. In order for it to be 128 pi, the height would have to be 2 pi, right? Because if my height here is 2 pi, when I go to find my length and width times my height, it's going to give me exactly what we want, 128 pi. All right, we have another one with similarity, right? So same deal, right? I'm not going to go through the steps of proving it. It should be kind of evident, right, that these two angles are going to be equal, that these two angles are going to be equal, and of course we have a shared angle, right? So the ratio, we can do this in 2 ways, right? I would say the ratio here, right, to here, so 6 to 12, really it's a 1 to 2 ratio, is the same as the ratio here to the whole thing, meaning x to 14. Right? We can also tell that from this side to the base is going to be times 2, meaning from this side to its base is going to be times 2. So if the base here is 14, that would make the base here 7. We've also got a 7 to 6 ratio here. We've got a 14 to 12 ratio there, which is 7 to 6. So we want the length of MN, which we said was 7. So this one we can do, I'm going to show the algorithm way. It might be easier just to use some choices. So with an inequality, an absolute value inequality, we usually do something called double switch. Double switch means that if I want to solve this one, I'm going to do 2 things. I'm going to keep it as is, right? In other words, what if the quantity inside is positive? And if the quantity is negative, we have to do 2 things. We need to switch the inequality symbol and switch the sign on the other side, okay, because of the nature of the way that absolute value works and the negative numbers work in general. So here, if I add 1, right, I'm going to get x is less than 4, and if I add 1, I get x is greater than negative 2. So really, negative 2 is less than x, which is going to be less than 4. And then we can do the same thing for the second one, right? So if I'm going to do my double switch here, I'm going to say that x, if it's positive, then everything stays as is. X plus 2 is less than 4. And if I want to hit my double switch, I'm going to say x plus 2. I'm going to switch my inequality symbol, and I'm going to switch the sign of the term on the other side. Technically on either side, but it's going to be easier to switch the right side. So here, if I add negative 2, I'm going to get x is less than 2. And here I'm going to get x is greater than negative 6. So that means negative 6 is going to be less than x, which is less than 2. So I need to try to combine these things, right? So here my minimum bound is negative 6, but that gets kind of trumped by this one whose minimum bound is negative 2, right? Because whereas negative 5 would work on the left, it's not going to work on the right. So we want it to work for both. So my final inequality is going to go from negative 2, and then I'm going to do the same thing here. Less than 4 works there, but something like 3, even though it works in my blue one, won't work in my orange one. So it's going to be, I'm going to defer to this. So kind of when I crunch these things together, in order for it to work for both, it's going to have to be greater than negative 2, but also less than 2. So I only got negative 1, 0, and 1, right? And if I check those, they're all going to work for both, okay? Now, could you have just said, oh, well, let me make a list of numbers, right? No, negative 5, negative 4, negative, and yeah, sure, you could do that, right? And you can see, well, now this is where it's going to cut off for the first one, this is where it cut off for the second one, and these are what's left over is what's going to work for both. All right, so we have a linear equation. So my slope is 2, out of 1, and my y-intercept is negative 2. So my equation, before I read anything else in this question, everyone should know the equation here is y equals 2x minus 2. Now it says that's f of x. Cool. So now it says which of these points is the y value bigger than that? So I want y to be bigger than 2x minus 2. So now it's a substitution question. If I substitute negative 2, I'm going to get negative 7 is bigger than negative 6. Well, that's no good. If I substitute negative 1 and negative 3, I get negative 3 is greater than 2 times negative 1 minus 2. Negative 3 is bigger than negative 4. Well, that's true. And that's the only one that turns out to work for all of them. I mean, for the equation. All right, 14. We have a irrational number, right? We have a denominator that is not rationalized, right? If you've taken Algebra 1. So it says which is not going to be rational. So we're going to say, none of these really seem initially rational. But if you take a radical and you square it, just for context, right? When we square a fraction, we square the numerator, we square the denominator. And we know that when we square a radical, we're undoing, right? Squaring and taking the square root are inverse operations. So these turn out to be rational, right? So both of those are going to be out. P is equal to Q, so P minus Q is 0. That's rational. The first one is P divided by Q. Well, anything divided by itself is 1. That leaves this. P plus Q. Well, 1 divide rad 2 plus 1 divide rad 2 is 2 divide rad 2. Well, that's definitely going to be irrational. So this is kind of like a weird, almost like a technicality question, right? Again, P minus Q just happens to be 0. P divide Q happens to be 1. The other ones you end up squaring radicals, which will be rational. Next one is a pretty easy substitution question, right? So could I write the equation like in point slope or slope intercept? I guess, right? But let's think about what we know, right? The x-intercept is 3. So the x-intercept is the x value when y is 0. So could I use 3, 0 and negative 3, 4 like I would normally do in Algebra 1 to write the equation? Sure, I could do that, right? In other words, the slope, right, is going to be, let's say, y2 minus y1 divide x2 minus x1, right? So my slope should be negative 2/3. Okay, well, that gets rid of a bunch of bad choices here. Now, the other thing I could have done, even if I didn't do that, is just substitute, right? 3, 0 is the easiest one. If I substitute 3, 0 in choice A, I'm going to get a fraction. If I substitute choice 3, 0 in choice B, right, I'm going to get negative 2/3 of 3, which is negative 2 minus 3 is negative 5. No good. If I use choice C, negative 2/3 of 3 is negative 2 plus 2 is 0, and that's what we'd want. And we already have the slope that we want, so negative 2/3 x plus 2. So again, either you can straight up substitute this point and then 3, 0, and you'll get your answer that way. I just found the slope so I could eliminate the bad choices with bad slopes, and then I just needed to substitute into those two other ones. All right, so consecutive integers, right? 7 consecutive integers, and their sum is 7k. So let's think about what I'm going to do. I'm going to make x my middle one, right? So I don't, if you're familiar with questions like this, you wouldn't really need to write all this out, right? But the reason we would make x the middle one is because the sum here, right, is going to be 7x, right? Because the negatives and the positives will have a sum of 0. So 7x is equal to 7k. All right, well, what does that really mean? It means that x was really equal to k. So what is really the second integer, k minus 2? All right, could you have done this with numbers? I guess, right? I haven't done it this way, but let's check it out, right? 1, 2, 3, 4, 5, 6, 7. So that's going to give me a sum of, what, 28? All right, so if 7k equals 28, then that means that k is equal to 4. So this is going to be 2 less than k, so k minus 2. So yeah, it works if we use numbers also. I prefer to use algebra, but it works with numbers. All right, this one's pretty hard. I got to say, this one was hard. So it says we start at 1, negative 2. All right, so maybe I'll use this table. We'll see. And it says there's 15 red flashes. Okay, so at each red flash, it goes 1 to the left and 4 up. So I'm going to go 15 to the left, so that means I'm going to be at negative 14 from 1. And I'm going to go 4 units up 15 times, so I'm going to go 60 units up. Okay, so after my 15 red flashes, this is where I'm at, negative 1458. Now it says that we're going to do some stuff where we're going to go 4 to the right and 5 down, and eventually y is equal to x. Okay, so my x coordinate, right, is going to go 4 to the right. So every time it's going to flash, if it flashes x times, I'm going to be going 4 to the right. So I'm adding 4 to my x coordinate. And every time my y it flashes, I'm going 5 down. And I want the left side, which is my x coordinate. I mean, let me replace that. So x as a coordinate, I understand how maybe we'll get confused, right? So let's say, it's n. Yeah, cool. All right, so I should be using n anyway. So negative 14 plus 5 for n, that's going to give me my new x coordinate. And this is going to give me my new y coordinate, and then my y and x coordinates to be equal. So this should be a pretty easy equation to solve. And then, of course, we'll check it at the end. So I get 9n is equal to 72, so that means n should be equal to 8. Right? Let's say you didn't do it algebraically, you can use the choices. You can say, what happens after we do this 8 times? Well, if I go 4 units to the right 8 times, I'm going to go 32 units to the right. So my new x-coordinate is going to be, I guess that's going to be 18. And if I go 5 units down 8 times, 5 times 8 is 40. And if I go 40, that's going to give me 18. And look at that, it checks out very nicely. All right, so I hope you guys enjoyed this. If you want more of the 9th grade videos, again, I kind of prioritize 8th grade, but if people need some of the 9th grade stuff, just let me know. You can drop a comment or a question. I'm happy to answer it. Thanks.